Did you know one man changed the meaning of time and space forever? He saw the universe not as it was, but as it could be, armed only with the power of his imagination. This is the story of Albert Einstein, the man who redefined reality itself. It began not in a grand laboratory, but in the mind of a quiet, curious child. From his earliest days in Germany, young Albert was captivated by the unseen forces that governed the world. He would recall a moment of profound wonder when his father showed him a simple pocket compass. The needle, quivering with an invisible energy, pointing steadfastly north, sparked a lifelong obsession. What mysterious power held it in its grip? This was the kind of question that ignited his mind, a question about the fundamental fabric of nature. Yet this innate curiosity was not always celebrated. The rigid rote-learning environment of the German school system felt like a cage to his free-ranging intellect. He was a student who questioned authority and resisted the mechanical drills of his teachers. They saw him as a slow, undisciplined daydreamer, one who would likely amount to nothing. His struggles continued as he sought a place in the world of academia, facing rejection after rejection. He eventually found work, not as a physicist, but as a humble clerk in the Swiss patent office in Bern. A third-class examiner. It seemed a dead end, a footnote in a forgotten story. But for Einstein it was a blessing in disguise. The simple, methodical work of reviewing patent applications freed his mind to wander, to soar through the cosmos on a beam of light. Then came the year that would shatter the foundations of physics. 1905, his annus mirabilis, or miracle year. From his desk at the patent office, this unknown clerk, working in near-total isolation from the academic community, unleashed for groundbreaking papers upon the world. Each one was a revolution. One explained the perplexing motion of tiny particles in water, proving the existence of atoms. Another described the nature of light, not just as a wave, but as a stream of individual particles, a concept that would earn him the Nobel Prize. A third laid the groundwork for a new understanding of time and space. And the fourth, an addendum, contained the most famous equation in history. Each paper alone would have secured a physicist's reputation for a lifetime. Einstein published them all in a matter of months. The most daring of these ideas was the special theory of relativity. For centuries, the universe was believed to operate on the fixed, absolute stage set by Isaac Newton. Time flowed at the same rate for everyone, everywhere. Space was an unchanging backdrop. Einstein dared to disagree. He proposed that the speed of light is the one true constant in the universe. Everything else, time, space, and mass, is relative, dependent on the motion of the observer. As an object accelerates towards the speed of light, time for that object slows down. And from this radical idea came a simple, elegant, and terrifying conclusion. E equals mc. Energy equals mass times the speed of light squared. It meant that mass and energy were two sides of the same coin, that a tiny amount of matter could be converted into a stupendous amount of energy. The secret of the stars was unlocked. Subscribe for more stories of genius and discovery. But Einstein was not finished. Special relativity was a masterpiece, yet it was incomplete. It did not account for gravity. For the next decade, he wrestled with this profound challenge. He imagined a person falling from a roof. In that moment of freefall, they would feel weightless. Gravity, he realized, was not a force pulling objects together, as Newton had described. It was a consequence of the shape of the universe itself. He envisioned a four-dimensional fabric, spaced, and what we perceive as gravity is simply the curvature of this fabric, warped and bent by the presence of mass and energy. Imagine a bowling ball placed on a stretched rubber sheet. It creates a dimple, a curve. A marble rolled nearby will not be pulled by the ball, but will follow the curve the ball has created. This, Einstein proposed, is how planets orbit the sun. They are following the curves in spacetime created by the sun's immense mass. He called it the general theory of relativity. It was a theory of breathtaking beauty and mathematical complexity. But was it true? The universe itself would provide the verdict. Einstein predicted that the immense gravity of the sun would bend the fabric of spacetime so much that it would measurably deflect the light from distant stars passing near it. The effect would only be visible during a total solar eclipse, when the sun's glare was blotted out. In 1919, the British astronomer Arthur Eddington led an expedition to the island of Principe off the coast of Africa to test this audacious claim. As the moon passed before the sun, plunging the world into an eerie midday darkness, photographs were taken. When the plates were developed and the measurements made, the result was clear. The stars had shifted their position, exactly as Einstein's equations had foretold. Newton's universe was gone. Einstein's had taken its place. Overnight he became the most famous scientist in the world. Though his name is synonymous with relativity, his Nobel Prize in Physics, awarded in 1921, was for his other 1905 paper, the one that explained the photoelectric effect. This work, which showed that light behaves as a particle, or photon, became a cornerstone of the new and strange world of quantum mechanics. It was a field he helped to create, yet one whose probabilistic nature he would famously struggle with for the rest of his life, stating, "God does not play dice with the universe. As his fame grew, the world around him darkened. The rise of Nazism in his native Germany forced the Jewish scientists into exile. He found a new home in the United States, at the Institute for Advanced Study in Princeton, New Jersey. But he could not escape the shadow of his own discovery. The equation E=mc now held a terrible promise. Horrified by the prospect of Nazi Germany developing an atomic bomb, he signed a letter to President Franklin D. Roosevelt, urging the United States to begin its own nuclear research. It was a decision that would haunt him. After witnessing the devastation of Hiroshima and Nagasaki, he became a tireless advocate for peace, nuclear disarmament, and global cooperation, dedicating his final years to warning humanity against the very forces he had helped to unleash. Albert Einstein's legacy extends far beyond the equations. He was more than a scientist. He was a philosopher, a humanitarian, a symbol of intellectual courage. He showed us that the universe is not only stranger than we imagine, but stranger than we can imagine. His theories were not the product of painstaking lab work, but of thought experiments, journeys taken entirely within the mind. He taught us that the most powerful tool for understanding the cosmos is not a telescope or a particle accelerator, but the boundless power of human imagination. He looked at a compass and wondered about the invisible. He rode a beam of light and changed the meaning of time. And in doing so, he proved that one person, armed with little more than curiosity and a pencil, could reshape our entire understanding of the universe.